Right, today we're going to go over section 9.4, which is called counting, counting methods. Okay, so let's jump right in. This says a pen has tip options of regular tip, fine tip, micro tip. So that's three different choices for the tip, the style of the tip. And then red ink or green ink. So how many different pen types are possible? So here you can see there's a table and it has regular, fine, micro, and then we can have a red regular or a red fine or a red micro. So that's three options there. Or you can have a green regular, green fine, or green micro, and that gives us a total of 6. So this multiplication product is very helpful when we're trying to count things. You can also think of it as a tree diagram here, visually seeing regular red or regular green, fine red or fine green, micro red or micro green. Not need to say red twice. Okay, I'll edit that later. The number of pens possible, again, is 2 times 2, which is 6. So this is called the fundamental counting principle or property. If a sequence of decisions is to be made, then the number of different ways of making all decisions is the product of the number of options for each decision. So here's another example. It says we have a meal which has 8 different appetizer choices and 10 entrees and 5, this says 5 desserts. So how many different meals can we choose? Well, you're choosing 3 things and you have 8 options for the first thing. You have 10 options for the second thing. And you have 5 options for the third thing. And so you multiply all these together, you get 400. That is how many different unique meal choices it would be. In a race with 5 horses, how many different first, second, and third places are possible? So this one you have to be a little careful since we're taking a place. So if the first place, if one horse is first place, he can't also be second place. So you see here that it's 5 times 4 times 3, simply because a horse can't be multiple places. So one of them is chosen for first, and then one of them is chosen for second. So then you have 3 possible options left to be chosen for third. You multiply those together to get 60. Now again, a little bit more difficult. In a certain small state, license plates consist of 3 letters followed by 2 digits. So 3 letters, 2 digits. How many different letters are there? Well, in the English alphabet, there's 26 possible letters. If you have 3 letter spots, that's 26 times 26 times 26. And then if you have 2 digits, oh, it says 2. I think it meant to say 3 here. 3 digit spots, you have 10 digits, 0 to 9, and then another 10, another 10. So you multiply all these together and you get 17,576,000 possible choices. Now, if letters cannot repeat, then all you have to think about is you don't get 26 every time. You have to subtract. So first you have 26 options, then 25, then 24, because you can't repeat the letters. But you multiply them just the same. If digits can't repeat, then same idea. It's just instead of the 26 going down, the 10 would count down to 9 and then 8. And again, you multiply them all together to get the answer due to the counting principle. How many, if there's no repeats, would be combining those two concepts, 26 and 5, 24. And another word to introduce to you guys is permutation. Permutation is an arrangement of objects in a particular order. Okay, so we're going to talk about 2 things in the next few minutes. One is called a permutation. The other one is called a combination. Permutation is particular order. So order matters. So EP, hopefully that will help you. So it has an example here. Find all the permutations of the objects A, B, C of size 2. So we're going to just pick 2 of them. So the order matters. It could be AB or AC or BA or BC or CA or CB. There are 6 permutations of size 2 from the 3 objects. If we want to know how many, we could also do the counting principle, which is in the first position, we have 3 choices. In the second position, we just have 2 choices. because we would have taken one of these away. We would have taken the A or the B or the C away. In general, the number of permutations of size R from n objects is abbreviated. It's NPR. Okay, there's a formula for NPR in general, and it involves factorials. All right, now a factorial, when you see that exclamation mark there, it is not just really excited. I remember one time when I was teaching high school, one of my students started yelling in the back, 7, 7. And I was like, what are you doing? And he was reading this with expression. So this is not an exclamation mark in mathematics. This is a factorial symbol. And all it means is you're multiplying a number times every number preceding it all the way to 1. So here are some examples. 2 factorial is 2 times 1. 2 factorial, 3 times 2 times 1. 4 factorial, 4 times 3 times 2 times 1. 5 factorial, 5 times 4 factorial, because it would be 5 times all these, which is 5 times 24, which is 120. And you continue in this manner for all factorials. One thing to mention is 0 factorial is just defined to be 1, simply because we don't want to divide by a 0. But the formula that is helpful for permutations is this one right here. It is one you would want to memorize. It is n factorial over n minus r factorial. Again, we use this whenever the order matters. Okay, you do this when order matters. So let's jump into some examples of permutations. 5 solo singers are to perform their acts in a nightclub. How many different orders of their appearances are possible? So this is 5, choose 5 permutation with 5, because you have 5 singers and they're going to take up the 5 spots. It's not only like 3 are performing or 2, all 5 of them are performing. So by the formula, we put the first number right here, goes on top. And then we subtract these 2, and that goes right here. 5 factorial we saw above was 120, and we defined 0 factorial to be 1, so we get 120. But you could find this out by just the counting principle that we were doing, which is just for the first act you have 5, for the second act you have 4, the third act you have 3, the fourth act you have 2, the fifth act you have 1. So same idea, just 2 different ways to get the answer. For a group of 6 people, a president, vice president, and secretary will be selected. How many different selections are possible? Okay, how many different selections are possible? So we have 6 factorial over 6 minus 3 factorial, because that's the formula. Now 6 factorial is written as 6 times 5 times 4 times 3 times 2 times 1. But notice that this work, oops, sorry. I didn't go 3 times 2 times 1. Instead, we just stop right here. I'm going to call this 3 factorial. We do that because it will cancel out easily at the bottom 3 factorial, which this bottom piece is always the difference of these 2. And so we get 6 times 5 times 4, which is 120. You get the same thing if we do it by the counting principle. 8 horses, how many different ways to get first, second, third? So that's permutation because the order matters. 8 permutated with 3, so we have 8 factorial on top. We have 8 minus 3, which is 5 factorial on the bottom. 8, 7, 6, 5 factorial. The 5 factorials cancel, so we get 8 times 7 times 6. And that is our answer. Now, combinations are different. Combinations are how you select objects where the order does not matter. So if we go back to our example above, where we had talked about when order mattered with A, B, and C, then these were counted as distinct, right? Because A, B was different than B, A. But if we don't care about the order, we just care about which 2 letters we chose, we have these doubles and we need to divide them out. And so then we would only have 3 combinations, not 6. So basically you have to realize the answer is usually smaller when you're talking about a combination instead of a permutation, and we have a different formula. So in general, the number of combinations, which is another formula to memorize, and this is when order does not matter. And this is going to be this guy right here. N factorial over R factorial over the difference. So we're going to go through several examples here and you'll be able to practice in your homework. A 3-person committee is to be selected from a group of 10. So the first number that you're writing over here is the total group, the total choices. We have 10 people, so that goes here. And then it's how many different what is my smaller subset? That goes here. And then on top, you put this one. And then you put this one on bottom for the combination, and then you put their difference. So the different piece in the combination versus permutation is how to divide out that 3 factorial. And then to simplify, we have 10 times 9 times 8 times 7 factorial. These 7 factorials cancel. So we get 10 times 9 times 8 over 3 times 2 times 1, which gives us 120. In a certain lottery, you must choose 6 numbers from 1 through 50. So how many choices are there? 50. You have to choose 6. It does not matter what order you pick the numbers in. So you put the big number on top, the small number on bottom, and the difference, and then you do the factorial. I will say if you have a calculator, you can actually type this in if you have a TI 83 or 84, if you hit the math button, math, and you go over to probability, and then you hit, so there's NPR, number 2 is NPR, and number 3 is in choose R. So if I want to do the in choose R, I can do that, and I can say 50, and then math, and choose R, and then 3, and then, hold on, not 3, 6. And then it will tell you the answer. So my calculator is really old, but you can sometimes use your calculator to figure out things like that. So you don't have to do 50 times or 9 times. There's also a factorial in the calculator. You get math and then over to probability as well to type in this factorial, math, probability, and then it's number 4 is the factorial. And one just really warning is if you're typing this in by hand, when you hit the divide key, make sure you don't do 50 factorial divided by 6 times 44 like this, because this will only divide this one and then it will multiply that. You want it to divide the whole bottom, so you need to put parentheses around the bottom, or you need to divide by each one because you're dividing by the 44 and the 6 factorial. So just be careful with that if you have an older calculator. You need to group the bottom together. Okay, now we're going to talk about groups that have men and women. The group consists of 7 men and 8 women. A committee of 4 people will be selected. So how many total choices are there? So again, this number over here to the left of the C represents the total. The total was the 7 plus the 8. So that was 15. And then what's the group size? This is the size of the group, which was 4. And so we put it into a formula and we get 1,365. How many 4-person committees are of 4 women? Well, this is how many total women are there? Well, this time our total, because this is just women. So this is total women. And then this is the size of the group that you're trying to make. How many 4 different committees consist of 3 women and 1 man? So I got 8 women to choose from. I'm taking 3 of them. So that's this first part. And then you have 7 men to choose from. You're only taking 1. That's this part. So you got 56 times 7, which gave us 392. How many different 4-person committees consisting of 2 women and 2 men? So very similar to the one above. It's just we have from the 8, we're choosing 2. And from the 7, we're choosing 2. You would plug them into the formulas and you would get 28 times 21, which is 588. How many different 4-person committees have at least 1 man? So a way to figure this out is to take the total number of committees, if we come back up here, and we subtract the number that have women only. So, because to have at least 1 man means we don't have only women. So you take 1365 minus 70 to get that answer. Now for our final topic in this section is finding probability using counting techniques. So this is really similar. It's just now we're talking about probability. So you don't have a part over a whole again. So how many different ways can these 4 people be seated? This is the counting theory. So 4 times 3 times 2 times 1. That's to figure out our total. There's 24 ways. how many different ways can Carl be seated in the first chair and Alan in the second chair? Well, the first chair, if it doesn't matter who's in that chair, you just put one. Okay, it can be anybody. The second chair, I want, oh no, sorry. First chair, we only want, sorry, Carl, there's only one Carl, so he goes there. The second chair, out of the 4 men, only 2 of them could be chosen for that second chair. Because, let me label this. Say this is Alan, Bob, Carl, and David. Oh, and your ABC. That's like my family. Okay, so if I want Carl to be seated here, and I want Alan to be seated here, so I got Carl, say he's in the first chair. How many people could go in the second chair? Well, he could go here, or he could go here. So the B or the D. So that's why you have 2 choices. But then once one of them is taken, you just have the one choice. And then A. So that's why that product is just 2. There's 2 ways. You could even list it out just to help you see it. If I could have C here, and I can have A here, and you could have the other 2. So the other 2 would be B and D like this, or you could have C here, A here, and D and B. There's only 2 ways that really those middle 2 can only be switched. The Carl stuck, Alan stuck. What's the probability Carl will be seated in the first chair and Alan will be seated in the first chair? Well, probability is taking part over whole. So how many ways could they be seated totally? 24. So that's this total at the bottom here. And then how many can they be seated in this particular way is 2. So 2 out of the 24 gives us that 112. A group consists of 4 men and 5 women. 3 people will be selected at random to attend a conference. How many different selections of 3 people from the group? Well, total people, when we're doing the combination, when order doesn't matter, we see that the total here is 9. So that's your total. And then this is your group size. And again, when we do that formula, it's 9 factorial over 3 factorial over the difference. Type that into your calculator and you can figure out what it is. What's the probability that 3 people selected? Okay, so you need to figure out the part over the whole. So how was the probability you would only get women? Well, out of the 5 women, you have 3 ways of getting that. So that's 10 choices where you would have only women. And how many total choices did you have? 84. So that's how you're putting out it's kind of like you're thinking of this as counting. Okay, the combinations are just counting ways for these things to happen. There's 10 options. We would have 3 women in the committee, or 3 women that were chosen to go to the conference. And then there's 84 total ways to count all those people. So 10 out of 84 gives you that 5 over 42. What's the probability that people are men? Well, that one you just have 4 men. So to figure out the different ways you could choose 3 from those 4 is 4 choose 3, which is 4. And then 9 choose 3, which was 84. So 1 over 21. What's the probability that the 3 people selected will consist of 2 men and 1 man? So this is putting it together. So you got 2 women, 5 choose 2, and then 1 man, there's 4 men. So again, just to reiterate, I know this can be confusing, but when we're choosing these numbers here, this is the total options of what we're talking about. So here, there's a total of 9 people, right? But here, we're just talking about the women, and here we're just talking about the men. So how many total women are there? 5. And then this is the size of the group, of the subset that you're trying to pick. How many of the women are you trying to choose? 2. So that, or then there's 3 in total, right? For this, there's 3 people total selected. There's 2 here, plus the 1 here gives us the 9, right? And the 5 here and the 4 here also gives us, 2 plus 1 gives us the 3, and the 5 plus 4 gives us the 9. So that should hopefully be helpful. Let's go on to the next one. 3 cards are randomly selected from a 52 card deck. What's the probability it will consist of all hearts? So how many hearts are there? There's 13 hearts. We're wanting to pick 3 of them. So there's 3 ways. This is the way that 286 options of 3 different hearts. Okay, you can have that many different combinations of choosing 3 hearts, 286 of them. And then of the 52 options, the 52 cards, you choose 3. There's 22,100 ways of getting 3 cards from the 52. So you're doing the part over the whole and you get 11 over 850. What's the probability it would consist of exactly 2 aces? Well, how can you get 2 aces? How many total aces are there? 4. And how many aces we're going to draw? 2. So you're doing 4, choose 2. And then what's the total non-aces? The total non-aces is 48, choose 1. Because 48, 49, 50, 51, 52. So 48 plus 4 gives us the total number of cards. So there's 48 non-aces in the deck. So we're wanting to pick exactly 2 aces out of the 3 cards. Okay, so that's why you have 4, choose 2. And then that only gives us the 2 cards. Then we need to pick one more card. We want it to be a non-ace. There's 48 options of that. That's why there's 48 right here. And then you're dividing it by the total number of ways to pick the 3 cards, which is the 52 is the whole total. And you're choosing the total of 3 for your smaller subset. And so that's what this answer is here. What's the probability it would consist of 2 aces and a king? So 2 aces again, like here, and a king. Well, how many kings are there? 4. We're trying to figure out how many ways you can pick one of those 4 kings. There's 4 ways. So when you're doing these probability problems where it's like you're picking multiple things, you have to consider each part over the whole. And so hopefully that's helpful. I'd like you to try and attempt your homework. And if you get stuck, please reach out to me. Good luck.